In 1912, Luther Burbank, the most famous plant breeder in American history, demonstrated trees grafted with dozens of fruit varieties growing from single trunks. He believed every home gardener should learn the technique. The nursery industry made sure that never happened. Burbank was not some obscure scientist working in isolation. He was a genuine national celebrity whose plant breeding achievements were so remarkable that Thomas Edison and Henry Ford traveled specifically to his California farm to meet him in person. He had created over 800 new plant varieties through his lifetime of dedicated work. Presidents sought his counsel. Newspapers covered his experiments. Schoolchildren learned his name alongside the great inventors and scientists of the American age. And he repeatedly stated in public lectures that the simple technique of grafting should be taught to every single person who grew food at home. He demonstrated how a single apple tree could produce dozens of completely different apple varieties from different branches on the same trunk. He showed how one citrus tree could grow oranges, lemons, grapefruits, and limes simultaneously without any conflict between the varieties. He explained in terms anyone could understand that any gardener with basic knowledge and a sharp knife could multiply their fruit production exponentially without buying additional trees, without needing additional space in their yard, and without spending additional money at nurseries. The nursery industry watched these public demonstrations with alarm. If home gardeners learned they could graft new varieties onto existing trees for free, they would stop buying new trees from commercial nurseries. If ordinary people understood that a single well-grafted tree could replace an entire orchard of separate expensive purchases, nursery revenues would collapse virtually overnight. If Burbank's passionate vision of universal grafting education became reality, the entire industry that profited enormously from selling individual trees for every desired variety would lose its fundamental reason to exist. So they made absolutely sure his vision never became reality. This is the story of the 4,000-year-old technique that could give every gardener unlimited fruit varieties completely free. The famous American who dedicated years of his life trying to teach it to everyone, and the billion-dollar industry that buried his dream to protect their profits. If this knowledge matters to you, subscribe and hit the bell. Let's begin. The science of grafting reveals why this ancient technique works so reliably that civilizations across the entire world have depended on it for millennia to preserve their most valuable fruit varieties. Grafting joins living tissue from one plant onto another plant, so they grow together and function as a single unified organism. The technique exploits the fact that plants heal wounds by producing undifferentiated cells called callus tissue. When cut surfaces from two compatible plants are held in firm contact, their callus tissues merge and differentiate into connected vascular systems that transport water and nutrients between them. The graft union becomes as structurally sound as natural growth within a single growing season, and the connection strengthens with each passing year. The lower portion of a grafted tree is called the rootstock and determines the tree's ultimate size, winter hardiness, disease resistance, drought tolerance, and adaptation to specific soil conditions. Nurseries have developed specialized rootstocks that produce dwarf trees, semi-dwarf trees, and standard-sized trees from identical scion material. The same apple variety grafted onto different rootstocks can mature at 6 feet tall or 30 feet tall, depending entirely on the root system supporting it. Home gardeners can select rootstocks that match their specific growing conditions and space limitations. The upper portion is called the scion and determines what fruit the tree actually produces. A scion is simply a small cutting containing a few dormant buds taken from a tree that produces desirable fruit. When grafted onto compatible rootstock, that scion grows into a branch that produces fruit absolutely identical to the tree it came from, genetically indistinguishable in every way. Additional scions from completely different varieties can be grafted onto other branches of the same tree, creating a single tree that produces multiple fruit types from the same trunk and root system. The compatibility requirements for successful grafting are broad enough that most fruit trees within the same general botanical family can be grafted together successfully. Apples graft readily onto other apples, onto pears, and onto quince rootstocks. Stone fruits including peaches, plums, cherries, apricots, and nectarines can all share a single rootstock and grow as branches on the same tree. Citrus varieties graft interchangeably with remarkable ease, allowing a single tree to produce oranges, lemons, limes, grapefruits, and tangerines simultaneously. A home gardener with one healthy fruit tree already growing in their yard has the rootstock needed to grow dozens of additional varieties, without purchasing anything except perhaps a few scion cuttings that cost almost nothing, or can be obtained completely free. Several different grafting techniques exist for different situations and skill levels. Whip and tongue grafting creates strong joints between scions and rootstocks of similar diameter. The technique involves matching angled cuts with interlocking tongues that hold the pieces together while they heal. Cleft grafting works well for adding new varieties to established trees by inserting scions into splits cut in larger branches. Bud grafting uses a single bud rather than a multi-bud scion and requires the least plant material to propagate new varieties. Each technique suits different situations, and all use the same fundamental principle of joining cambium layers between scion and rootstock. The history of grafting stretches back over 4,000 documented years to ancient civilizations that understood its extraordinary value immediately upon discovery. Chinese agricultural texts from 2,000 years before Christ described grafting techniques for improving fruit production and preserving superior varieties. The Chinese recognized that exceptional fruit trees could not be reproduced through seeds and developed grafting methods to maintain their best varieties across generations. Imperial gardens contained grafted trees bearing multiple fruit types that demonstrated the technique's possibilities to visitors from across the ancient world. The knowledge spread along trade routes to other civilizations, eager to improve their own orchards. Mesopotamian farmers grafted date palms to ensure reliable harvests of desirable varieties in the Fertile Crescent. Date palms were essential food sources in the ancient Middle East, and grafting allowed farmers to propagate the most productive and flavorful varieties rather than gambling on seed-grown trees that might prove worthless. The technique became standard agricultural practice, so fundamental that it appeared in the earliest written records of farming methods. Greek and Roman agriculturalists wrote detailed grafting instructions that remain accurate and completely useful today. Roman agricultural writers, including Cato, Varro, and Columella, devoted substantial portions of their farming manuals to grafting techniques, timing, and variety selection. These texts were copied and preserved through the medieval period and formed the basis of European orcharding knowledge for over 1,000 years. The Romans spread grafting knowledge throughout their empire, along with the fruit varieties they grafted. An apple seed planted from the most delicious apple you have ever eaten will grow into a tree, producing fruit that tastes nothing like its parent. This fundamental biological fact explains why grafting became essential to fruit cultivation. Sexual reproduction in fruit trees shuffles genetics randomly, producing offspring as variable and unpredictable as human children are from their parents. A seed from a perfect peach might grow into a tree bearing small, bitter, worthless fruit. A seed from a flavorful apple might produce a tree with mealy, tasteless apples. The only way to reproduce a specific fruit variety exactly is through cloning. And grafting is the cloning technique that has preserved desirable fruit varieties for thousands of years. Every Honeycrisp apple, every Bartlett pear, every Bing cherry you have ever eaten came from a grafted tree propagated from the original variety through generations of grafts. The Honeycrisp apple was developed in 1960 at the University of Minnesota. Every Honeycrisp apple tree in the world descends through grafting from that original seedling. The Bartlett pear originated in England in the 1700s, and every Bartlett pear tree traces back through grafts to that single discovery. Without grafting, these varieties would have existed for one tree's lifetime and then disappeared forever when that tree died. The nursery industry knows this perfectly well because grafting is exactly how they produce every fruit tree they sell. Commercial nurseries graft constantly and continuously. They maintain entire orchards of rootstock grown specifically for grafting operations. They collect scion wood from variety trees and graft thousands upon thousands of trees for sale each season. The technique is so fundamental to their operations that no commercial fruit tree reaches market without being grafted by skilled nursery workers. Yet they never mention to their paying customers that the same technique they use professionally every single day could eliminate the need for customers to ever buy from them again. Luther Burbank understood that democratizing grafting knowledge would fundamentally transform home food production, and spent years of his life trying passionately to spread that knowledge to ordinary people. Burbank's experimental farm in Santa Rosa, California, attracted visitors from around the world who came specifically to see his remarkable plant breeding results and learn from his methods. He used these visits as opportunities to demonstrate grafting techniques and explain in simple terms how any gardener could apply the technique successfully at home with minimal equipment and no special training. He showed visitors trees bearing dozens of different fruit varieties created through successive grafts added over the years on different branches. He emphasized repeatedly that the technique required no special equipment beyond a sharp knife, no advanced education or scientific background, and no significant financial investment whatsoever. He believed with conviction that grafting knowledge should be as common among gardeners as knowledge of planting seeds. His books and articles reached hundreds of thousands of eager readers and included detailed grafting instructions, written specifically for complete beginners with no prior experience. He explained the simple steps in clear language anyone could follow. Make a clean cut on the rootstock at an angle. Make a matching cut on the scion wood, bind them firmly together with string or grafting tape, and protect the union with wax or paint while it heals over the following weeks. He described the optimal spring timing when bark slips easily from the wood and grafts take most reliably. He encouraged his readers to experiment fearlessly with different techniques because failed grafts cause no permanent harm to the tree, and successful grafts provide fruit for decades to come. Burbank saw grafting as the key to food independence for ordinary American families. A family with one apple tree could graft 20 different apple varieties onto it and have fresh apples from early summer through late fall harvests. A family with limited yard space could grow peaches, plums, and apricots all from a single multi-grafted tree, rather than needing space and money for 3 separate trees. He envisioned American yards filled with diverse grafted trees, providing families with fruit abundance that would otherwise require expensive commercial orchards. Burbank died in 1926, and his vision of universal grafting education largely died with him. The nursery industry continued selling separate trees for every variety at prices that made orcharding expensive. Agricultural education continued ignoring grafting as a home skill that ordinary people could master. Generations of American gardeners grew up buying trees without ever learning they could create unlimited varieties themselves from trees they already owned. The modern nursery industry generates over $50 billion annually by selling plants that customers could often propagate themselves for free. A single grafted fruit tree sells for $20 to $50 at retail nurseries. That same tree began as rootstock, costing the nursery pennies, and scion wood that costs nothing because nurseries collect it from their own variety trees. The grafting labor takes a trained worker minutes per tree. The markup from production cost to retail price approaches 1,000% or more. This profit margin depends entirely on customers not knowing how to graft their own trees. Scion wood for any fruit variety is available free from gardening communities that exchange cuttings gladly. Online communities, local gardening clubs, and extension programs all provide access to scion wood from hundreds of fruit varieties for nothing more than the asking. A home gardener who learns basic grafting technique can acquire new varieties endlessly without ever purchasing another tree. The $40 tree at the nursery represents scion wood that was free and rootstock that could be grown from seed or purchased for a few dollars. The contrast between what nurseries charge and what grafting actually costs reveals why the industry discourages grafting education. Every gardener who learns to graft represents a permanent loss of tree sale revenue. Every community that shares grafting knowledge becomes independent of nursery purchases for new varieties. Every video or article teaching grafting threatens the business model that depends on keeping the technique mysterious and inaccessible. Learning to graft requires less time than learning to drive a car and provides benefits that last a lifetime and can be passed down to future generations. The basic techniques can be learned in a single afternoon from freely available instructions online or in library books. Whip grafting, cleft grafting, and bud grafting. Each suit different situations, and all use the same fundamental principle of joining cambium layers between scion and rootstock. A sharp knife, some grafting tape or rubber bands, and a source of scion wood are the only requirements to get started. The first attempts may fail as you learn the feel of proper technique, but failure teaches what success requires. And even modest success rates produce more new varieties than most gardeners could afford to purchase at nursery prices. Spring is the optimal grafting season when sap flows strongly and bark separates easily from wood. The timing window extends several weeks, providing multiple opportunities to practice before the season ends. Most grafters find their success rates improve dramatically after just a few attempts, as they develop feel for the cuts and wrapping. By the second season of practice, success rates routinely exceed 90%. A single successful graft costs essentially nothing and produces fruit for decades. The 30 minutes spent grafting a new apple variety onto an existing tree replaces a $40 nursery purchase that would require years of growth to reach production anyway. The grafted branch begins producing fruit much sooner because it benefits immediately from the established root system of the host tree, rather than starting over as a young tree would. Multiple grafts create a multi-variety tree that provides diverse harvests from a single planting space that would otherwise support only one variety. Every successful graft you make is a fruit variety you never need to purchase. Every tree you add varieties to through grafting is a tree's worth of nursery sales you will never provide. Every skill you develop in grafting is knowledge you can share with other gardeners, spreading the independence that the nursery industry has worked for over a century to prevent. Luther Burbank believed this knowledge belonged to everyone who grows food. He demonstrated it publicly at every opportunity. He wrote about it clearly in language anyone could understand. He advocated for it passionately in lectures and interviews throughout his famous career. The industry that profits from keeping gardeners dependent on purchased trees made absolutely sure his vision never reached the mainstream consciousness. 4,000 years of proven technique across every civilization that grew fruit. One famous American who dedicated his life to teaching everyone. $50 billion in annual nursery sales, depending completely on you never learning what he knew. One tree can grow 40 different fruits. The technique takes a single afternoon to learn. The scion wood is completely free. They made sure Burbank's dream of universal grafting knowledge died with him in 1926, because every gardener who learns to graft is a customer they lose forever. Now you know what the most famous plant breeder in American history wanted every gardener to learn. Now you understand why the industry that sells you trees made absolutely sure you never did. If this opened something for you today, subscribe and hit the bell. Every single like and share spreads what the nursery industry has spent a century keeping from home gardeners. See you in the next one.